Alright, today we're going to talk about how to solve systems of equations algebraically, and we're going to start with the method of substitution. So substitution is a really effective way to solve systems. It's very simple, very straightforward. So the way this works is that one equation is solved for one variable, and you get to choose which one. It's totally up to you. And so if it's necessary, I'm going to rotate this, sorry. If necessary, at least one equation for one of the variables we're going to solve. And then we're going to substitute the remaining expression from step 1 into the other equation to replace the variable. Then we're going to solve the equation. So we're going to substitute the value from step 2 into either equation to solve for the other variable, and then we're going to write our answer as an ordered pair. So the way this works, example 1 here, we have start off with 2x plus 5y equals 19, and then we have y equals 3x minus 3. So we've already isolated y by itself. So what we're going to do is we're going to take what y is equal to, this 3x minus 3, and we're just going to substitute it in to this y spot right here in the first equation. So we're going to have 2x plus 5, and instead of writing the y, I'm going to write what y is equal to, which in this case is 3x minus 3, and then the equals 19. So what we're going to do now is we're going to distribute this 5. So 2x plus 5 times 3x is 15x, 5 times negative 3 is negative 15, equals 19. Combine our like terms, we get 17x minus 15 equals 19. Add 15 to both sides. We get 17x equals 34. Divide both sides by 17. And we get that x is 2. Alright, now I'm going to take this 2, and I'm going to plug it into either one of these equations I started off with and get what y is. So I'm going to do y equals 3 times 2 minus 3. So 3 times 2 is 6, and 6 minus 3 is 3. So my solution is 2, 3. Alright. Next, this one, I do have to get one of my variables by itself. Now, truthfully, it does not matter which one you do. You can choose either x or y, and you can choose either top or bottom. So you really have 4 choices. You just need to pick a variable to try to isolate. I will tell you that in this equation, there is one of them that stand out as the easiest to isolate, and that is this x in the second equation. So I want to get that x by itself. In order to do that, all I have to do is subtract 2y from both sides. And that gives me x equals negative 2y minus 12. So we had negative 12 there. So now I'm going to take what x is equal to, this negative 2y minus 12, and I'm going to plug that into the first equation for that x. So this is going to be 8 times negative 2y minus 12, and then minus 3y equals negative 1. So now I'm ready to distribute. 8 times negative 2y is negative 16y. 8 times negative 12 is negative 96. And now I need to combine like terms. Negative 19y minus 96 equals negative 1. Add 95 to both sides. I get negative 9. Make sure I write that correctly. Negative 19y equals, went ahead of myself there, 95. And then I'm going to divide both sides by negative 19. And I get that y is equal to negative 5. Alright, so now that I have y equal to negative 5, I'm going to take that value, I'm going to plug it into one of my original equations. It truthfully does not matter which one you choose. So I'm going to do 8x minus 3 times negative 5 equals negative 1. Negative 3 times negative 5 is positive 15. So if I subtract 15 from both sides, I get 8x equals negative 16. Divide both sides by 8. I get x is equal to negative 2. So my solution is -2 comma -5, and that is where those lines intersect. All right, number 3 is kind of a weird case, and I'll show you why as we go about here. I have isolated y, so y is equal to 2x minus 11, so that goes in right there for that y in the first equation. So -10x plus 5 times 2x minus 11 equals -30. And then -10x plus 10x minus 55 equals -30. Now I have a -10x and a +10x. When I combine those like terms, those cancel out. So all that's left is -55 equals -30. Now that is not a true statement. So because that is not a true statement, it's not like we made a mistake anywhere. We didn't have a typo or something. We actually have parallel lines. So there are no solutions. Oh. And I can prove that those are parallel lines. Remember, parallel lines have the same slope. Let's look at this equation again. -10x plus 5y equals -30. -30. So, if I want to get y by itself, I'd add 10x to both sides to get 5y equals 10x minus 30. Then divide both sides by 5. Gives me 2x minus 6. Now look, what is the slope? 2. What's the slope of the other one? 2. Look, they have the same slope. So they're parallel. They're not the same line because look, my y-intercepts are different, -11 and -6, but they do have the same slope, so they are basically parallel. They're never going to cross. All right, number 4 is another special case. We have y equals something and y equals something. So if y is equal to 4x minus 1 and y is equal to 2x minus 5, I can take what this y is equal to and substitute it in for the other y. So we can set this up as 4x minus 1 equals 2x minus 5. And now we're ready to solve. I can subtract 2x off of both sides. Get 2x minus 1 equals -5. I'm going to add 1 to both sides. Get 2x is equal to -4. Divide both sides by 2 to get x equals -2. And then I'm going to take that -2 and plug it in for either of the x's up above. Y equals 2 times -2 minus 5. 2 times -2 is -4. And -4 minus 5 is -9. So, -2, comma, -9 are my solutions. Alright. So now, to the second method. A lot of fun. This was actually my favorite thing to do in Algebra 2, and that is elimination. Elimination is the process of using addition or subtraction to eliminate one of the variables. So if one of the variables in both equations does not have opposite signs, you're going to multiply one or both of the equations by a number to result in two equations that contain opposite or equal terms. And then we're going to add or subtract the equations, eliminating one variable, and then solve the equation. And then lastly, we're going to substitute that value from step 2 into either equation and solve for the other variable. And then we'll write our answer as an ordered pair. So, we're looking for opposite coefficients. Opposite value coefficients. And if you look at number 1, we already have opposite value coefficients. Our y's are opposite values. One is -9, one is +9. So, we are going to have to add these two equations together. -2x plus -4x, that becomes -6x. -9y plus +9y becomes just 0. They cancel each other out. And then we're going to add the -25 and the -23. That equals -48. So I have -6x equals -48. Now I'm going to divide both sides by -6. And that leaves me with x equals 8. So now that I have an x value, I'm going to plug that into one of my original equations. It doesn't matter which one. -4 times 8 plus 9y equals -23. -4 times 8 is -32. And add 32 to both sides. get 9y equals 9. Then divide both sides by 9. Get y equals 1. So my ordered pair is 8, 1. Now, for number 2, I do not have opposite coefficients yet. Opposite value coefficients. So I'm going to need to do a little bit of manipulation. I need to turn one of these coefficients into the opposite value of the other. So I have a positive 14 and a positive 7 on top, a negative 2 and a negative 1 on the bottom. So if I were to multiply that bottom one by 7, I would be able to create an opposite coefficient. So what I'm going to do is just move it over here, rewrite the first one. I didn't do anything to the first one, just rewriting it as is. This bottom one I multiplied by 7, so I'm going to multiply everything by 7, not just the left side. I got to do the right side as well. So that becomes negative 14x minus 7y equals 7. So now I'm ready to add those together since I have opposite coefficients. 14x plus negative 14x, well, that's 0. 7y plus negative 7y, well, that's also 0. And then negative 2 plus 7, that's going to be 5. So I end up with 0 equals 5. Well, that is not a true statement. So just like in the last one, anytime I end up with a false statement, that means there are no solutions. And if you were to figure out get y by itself, you would see that both of those have the same slope. So these are parallel lines. So that's why there's no solutions. Now, if you look at this next one, number 3, we have a positive 12x and a negative 3y on top, and a negative 12x and a positive 3y on bottom. So I have opposite coefficients, so I can go ahead and add these together. And negative 12 and positive 12, those add together equal 0. Negative 3 and positive 3, those add together equal 0. And then 6 and negative 6 add together equal 0, so I end up with 0 equals 0. Well, that is a true statement. So what that means is it's not that we have no solutions, it's that we have an infinite amount of solutions. Infinite solutions. Because what we have is coinciding lines. These lines are on top of each other. They are coinciding. All right, next one. I have negative x plus 5y equals 8. 3x plus 7y equals negative 2. I have no opposite coefficients. So what I need to do is create some. Now I have this negative x on top and a positive 3 on bottom. So if you think about it, what could I multiply negative 1 by to make it equal 3? Well, I could multiply it by 3. So if I multiply this top by 3, I got to do the left and right side. I should have a opposite value coefficient now. So 3 times negative x is negative 3x. 5 times 3 is 15y. And 8 times 3 is 24. And the right side, or the bottom one, stays the same. Didn't do anything to the bottom. So now we're ready to add those together. Negative 3x plus 3x, that's 0. They cancel out. 15y plus 7y, that's 22y. And then I have 24 minus 2, that's 22. Divide by 22, y equals 1. So our y is 1. So now we're ready to plug that back into one of my original equations. So 3x plus 7 times 1 equals negative 2. So that's 3x plus 7 equals negative 2. Subtract 7 from both sides, you get 3x equals negative 9. Divide by 3, and x equals negative 3. So my solution is negative 3, 1. Remember, x always has to come first in the ordered pair. X will always be first. All right, that is it for this these notes. If you have any questions, please shoot me an email or call Canvas message, and I will get back to you as soon as I can. Have a great day.